So now we're going to sketch this graph using all the information we have previously found. The first thing that I'm going to do is put a line as to where my graph is centered, and that's related to this vertical translation that has occurred. And it's shifted the graph down to minus pi on 3. So let's just come here and put a dotted line there. You should use a ruler, and this also should be in pencil because you are going to rub this out towards the end. Then I'm going to look at my amplitude. I'm going 2 up from this point, so it will be here. So this is going to be 2 minus the square root of 3, and we're going to put a dotted line there. And then I'm going to go 2 down from this line, so it will be about here. This will be minus 2 minus the square root of 3, and it will be here. Hopefully your graph lines are a bit straighter than mine. This is a bit wonky. Okay, that's good enough. Okay, the next thing that I'm going to do, remember when we were finding out information, I talked about where we're going to start sketching. So this isn't where the graph is actually beginning, but just where I'm going to start sketching. And it's going to be negative pi on 3. So the reason why we did that is because what we like to think of is that this is a normal sine graph that has been shifted back by pi on 3. So it's going to be here. That's where I'm starting from. What I'm going to do now is I'm going to take this starting point, which is negative pi on 3, and I'm going to add on my scale to it. So remember, we found what the scale is. If we come back up here, we found that the scale was going to be pi on 2, and the scale here is actually going to be quite useful in helping us draw a nice accurate graph. In order to add on the scale nicely onto this starting point, I'm going to have to get them into the same denominator. So I'll times this by 2, so negative 2 pi on 6, and I'll times this by 3, so it'll be 3 pi on 6, both the denominator and the numerator. So that means I'm starting at negative 2 pi on 6, and I'm going to add 3 pi on 6 each time. So that will take me here to pi on 6, and then that will take me to 4 pi on 6. Then it will take me to 7 pi on 6, and then it will take me to 10 pi on 6. And then it will take me to 13 pi on 6. But you can see I've gone too far there because I want to stop at 2 pi. Then I also need to go back because you see my domain is negative pi back. So if I'm starting at negative 2 pi on 6 and I'm going back 3 pi on 6, that's going to take me back to negative 5 pi on 6. And then if I go back again, that's going to take me to negative 8 pi on 6. And that's taken me back too far because remember, I don't want to go past negative pi, and that is past negative pi. So I'm going to stop somewhere here. Maybe even a bit closer to this one. It would be closer to here, wouldn't it? It'd be about there. Perfect. Not the prettiest thing at the moment, but you know, it's okay. The next thing that we're going to put in is our x-intercepts. So if we come over here, we know that we have x-intercepts at 0 and pi on 3. So if I come here, oh, actually, you know, before I do, no, we'll do it. I have an x-intercept here at 0, 0. That's important for when I graph it, because I have to make sure that I get that right. And I also have another one at pi on 3, so that will be about here. All right, let's now just give this thing a bit of a sketch, and I might just write this as pi on 3. All right, so I'm going up and down. Good. And then I'm actually stopping. If we look up here, remember we found where we're going to stop. So the end is 2 pi on 0. So it's actually going to end at the x-intercept. So I might actually, this is where it's actually a bit handy. It's going to end like there. 2 pi 0. Now, this is not the prettiest graph in the world. I might even actually try to make it a bit prettier. It's a bit wonky, but that's fine. So at this point right here was pi on 3. So I have this endpoint labeled. I have all my x-intercepts labeled, but now I actually have to go backwards as well. So I'm going to go back. So it's going to hit the minimum there, and then it's going to stop here. And that point right there, we found when we were over here, it's going to be negative pi minus 2 pi on square root of 3. This is where we're going to start cleaning up. This is why you have to use a pencil when you're doing this. So this is going to be it'll be negative pi minus 2 the square root of 3. Okay, now this is where you're going to start rubbing things out to make it a bit prettier. So let's get rid of all these black lines. We'll leave that right there. Wait, get rid of that. Get rid of this. Get rid of all of these. We don't need these numbers. We don't need that number. We don't need that number. I might write that as a coordinate just to make it look a bit prettier. We don't need any of that. Perfect. And that's what our graph is going to look like. These things are a bit fiddly to draw. This should look a bit straighter. And sometimes like that. That looks actually not too bad. I mean, let's not delude ourselves. It's not fantastic, but it's not half bad. So that's what it's going to look like. So we took all our information and we gave it a sketch. If you want to see what this looks like on Desmos, we can come here now and let me just show you what a really nice one would look like if we come here. So as you can see, we've got one at 0, one at pi on 3, one at 2 pi on 3, and you've got all your points here that is labeled. And then you can see also that I have my endpoint there at negative 2 the square root of 3, just like that as well. So that's what it looks like if you were to draw it like that. And we have. Hopefully you found this useful. Bit of a fiddly one, but hopefully you have fun drawing yourself some graphs.